Hello everyone, I welcome all on Data Phoenix webinar. Today we speak about open source LLMs, and with us Andrey, who is the founder of dstack. Year ago we speak about dstack and show our audience these cool tools, and today we continue to show what dstack can do, and we'll see how it's growing and how you can use it for LLMs. Also, we will speak about some economic part and of hosting open source LLMs, and how you can train and how you can serve the model using these tools and other tools, I hope. So you can ask the questions using Slando. The link is under the video, and we will answer for all your questions after Andrey's presentation. So I give to him microphone.
Awesome. Thank you, Dmitry. Pretty excited about speaking today here and talking about LLMs. Yeah, like Dmitry said, last year, that was exactly when we made their first open source tool to orchestrate ML workloads. But today we're gonna talk not about dstack, but mostly about open source LLMs and how to leverage them for production. Before I begin, I'd like to maybe ask chat to share more about your experience, whether you are using LLMs, whether you are using proprietary tools like OpenAI or already using open source LLMs. And if not, then whether you are looking soon or just join the event to know more in general, but don't have necessary plans. So please do share about yourself as much as you can, because it is very important for us also to understand what is the audience. So it is just very important for me personally. But then that's probably all the intro from my side. So I'll go directly to the topic of open source LLMs. Right. So open source LLMs, and the first question I'll be wondering about is why to use them at all. Even though some of you might not have knowledge of open source LLMs, most of you already have certain experience with ChatGPT. And is a product that runs on top of an LLM, a proprietary one, one built by OpenAI. And it's a pretty cool product, and it's super powerful, and you can do so many things with it, and it's very easy to use. So the question is why at all to bother about open source? For at least 4 reasons. First one is probably most important one is control. When it comes to using LLMs, you often integrate them into your applications. And application, as a business owner, you are in a situation when your business depends on the behavior of the model. And when it comes to proprietary LLMs, this is not something that you have full control of. You don't control the behavior of the model, and you also don't have entire of the you cannot avoid the situation when the behavior of the model changes, and your business might be at risk because of such an event. Then another one is a customization problem. Using a proprietary LLM, you cannot customize the model behavior except, well, what you build on top of that LLM. However, in case of open source LLMs, there are many ways you can customize open source LLMs. One is train an open source LLM using some enhanced or totally different data sets and build another LLM on top of it. You can also follow the guidance from an open source LLM and build another one, changing some approach. Open source LLMs are trained. You take the best approaches from other open source models and then experiment with it and get newer, better, different versions of LLMs. And then, of course, you can fine-tune open source LLMs on custom many different techniques to get very specific behavior. And getting back to the control, when you are deploying an open source LLM or fine-tuned version of an open source LLM, you always have entire control and you can always roll back, and you basically own the weights of the model, and you always know how the model will behave, render. Then one more reason is, of course, cost. And we know at least two things about, for example, OpenAI. On one hand, the pricing has been decreased recently by OpenAI. However, GPT-4, for example, is still quite high, and it depends on the usage directly. So if your usage grows and they charge you per token, then well, you have a risk of having your expenses growing linearly to the usage. At the same time, the smaller version of GPT, which is called GPT 3.5, is quite cheap to use. It doesn't have the quality of GPT-4, but still it's quite cheap to use. However, there are many things that you could achieve LLMs. For example, well, if you fine-tune a model, an open source LLM on a specific domain, you have a chance to use a smaller model with a better quality, and you can also leverage buttons, and by this, your costs, instead of being linear, can have this logarithmic scale, which is a very cool thing if you are using an LLM. When finally, privacy. Privacy is a broad topic, and we might not go into the very deep into this topic. I would just say that open source LLMs have a lot more control over the privacy, where your inference happens, and if you might have a lot of concerns over privacy, and that's one more reason to prefer open source LLMs. Right. By no chance, this talk is going to cover all the known open source LLMs. So if you follow, open source LLMs appear pretty much every day, and those are great models. So there is a constant flow of improvements with open source LLMs. I would just mention three most important models from my subjective point of view, which you have to know. And the first one is, of course, Llama 2. Llama 2 is the second version of local Llama, so-called. This is a model by Meta, which was shared in partnership with Microsoft and is offered in 3 different sizes. So model size is a number of which is a way to say how the model is large, how model is big, how many parameters were used to train it. And it operates in like 7 billion parameters, 13 billion parameters, and 70 billion parameters. So you can expect that the quality is typically better in general. And Llama 2 is offered into flavors. One flavor is a base model. Base model just completes text, any text. You give it a beginning of a text and text to generate, and it generates it. And another flavor of this Llama 2 model is conversational model, or also called chat model. It is the same base model, but fine-tuned for conversations. Probably we'll mention that later, how that is different. But you can think of it as this conversational model is more friendly for human conversations. And it may answer questions, it may follow previous messages, the constructions, which is very important for an LLM. Then there is Code Llama, which is a fine-tuned version of Llama 2, also by Meta, also offered in 3 sizes, even though the largest model is smaller than the standard Llama 2. But what is special about Code Llama is natural language, but it's very good at generating code instructions. And this is very cool because unlike normal Llama, which generates text, which we can generate instructions. For example, you can generate SQL queries and automate, for example, the access to data on your behalf, or it also can generate JSON, which can be used to generate API calls, which is a totally different level of automation. Opens a lot more use cases for adopting LLMs. And finally, I would like to mention Mistral. It's a relatively new model, so it was released quite recently, and it was released by a company, Mistral AI. Approach. They did some they followed a bit different way of training the model. So the objective was to train a very small model, but which would be quite performant. So 7 billion parameters variant, but it can be compared. So it's right now it's the best quality for this size of models, and even more, it beats also 13 billion parameters model. So it's just another way sizable, quite well performing very small model. Right. So to give you a feeling of what Llama 2 is, this is some data from the original paper on Llama 2 about the largest one, where it shows how the model behaves with different benchmarks compared to ChatGPT and some other models like a Spell. So benchmarks are just a way to see how models, like for example, the first one is MMLU, is a massive multitask language understanding. It just measures how well the model performs across a variety of different tasks. So what you can see here is that Llama 2 comes really close to the quality of with this particular benchmark, and not that far behind with other benchmarks, which makes it possible to claim that Llama 2 in terms of quality quite close to GPT 3.5, at least when it comes to these general benchmarks. But what we also can see is that it falls behind greatly GPT-4. So GPT-4 is doing a lot better on all benchmarks than Llama 2. And for example, you can also mention, notice this human eval. Human eval is a data set which measures how a model following technical instructions and generates. So, for example, was not trained for that at all. So this score is very low. But we will talk about code generation in later in the further slides. Here's some, and basically it just shows that Mistral 7B is better than all other small models like Llama, and it is better than not only 7B Llama 2 model, but 13 billion parameters, which is just another way to say that Mistral is probably one of the best smallest models. Right. So here's some study by Snowflake, where they of different sizes and the specific use case, code generation, and in their particular case, they generated SQL queries. And what they learned through this study is that even though they took this smallest model and fine-tune it, it's the same as if they would fine-tune a larger Llama model, and it wouldn't be very far from the quality of GPT-4. So basically, to make it short, it's very efficient. Llama 2, even the smallest model, is super efficient for fine-tuning problem, and it is relatively easy to come very close to the quality of GPT-4. This is another data. There are two other companies that took code Llama, and then they fine-tune it on the 2-bit GPT-4 at code generation. And when they did that, they actually succeeded. And at the time of the announcement, both Wizard Coder and Find, they made a model that bet GPT-4 benchmarks. However, here in the table, you see if you compare how models behave, GPT-4 is still better. It is because in April, GPT-4 released a new version where they decided to improve the quality of the model when it comes to code generation. So GPT-4 is still the best for code generation, but what these companies have proven is that it is possible to fine-tune an open source model to challenge GPT-4. And these open source models for code generation are quite efficient. So it is now interesting to some economical aspects. Here is a slide from their application. It is a gradual application that you can find on Hugging Face Spaces, which you can give any model, and it will calculate how much memory for inference or training, if you don't use any optimization techniques. So this one shows if you take their full precision. Full precision is another way to say that, well, if you can think of it this way. A model consists of weights, of numbers, a lot of float point numbers. And you can store these weights either in float point 32, it's called full precision, or you can also store it as half precision. So basically, if you took their just full precision of this Llama 270B billion, you'll see that the total size of this model is 256 gigabytes. It means that it won't fit any GPU. You wouldn't be able to use this model for inference with one GPU. And for training, as you see, using the standard optimizer called Adam, you would need at least one terabyte of GPU. So basically, it means that it's just fine-tune this model. You basically need lots of GPUs or lots of machines with GPU. And we are talking here about this Llama 2 70 billion parameter model. Right. Here's another study by Hugging Face with AWS. So they basically took Llama and then they calculated the latency and throughput and also costs, inference costs. And what they got is that, for example, if you look at their largest version of the model, Llama 2 70 billion parameters, they managed to run it only using the AWS can offer. It's instance that offers 8 GPUs, 80 gigabytes of GPU memory each, A100, which is super expensive. And the latency, milliseconds per token, is 41, which is very low, but well, okayish. And then they, for generating 1 million of tokens, it basically costed for $400, which is pretty expensive. I mean, no surprise here because we are using AWS can offer. Which brings us to the question of whether we can significantly drop their requirement and the cost of using this model. And this is why we will talk about quantization, which is an optimization both inference and training. So think of it this way. If you have an LLM, it consists of weights, which, as I said, stored in float point, which and every float point takes a certain memory, and you need to put all of these float point weights into the GPU memory or CPU memory. However, it is possible to turn float point into a lower rank, and then thus memory. So this technique, quantization, when we transform a float point into, for example, int8 vector, and as you see here on the slide, very simplified explanation how it works, we take possible to fit a large model into smaller memory. So there are different approaches. One is int8, another is int4. You can also use int2, but the general idea is that we lowering the weights. And the whole point here is not only to do that, but also to make sure that we don't lose the quality significantly. And this technique is pretty efficient. Means that we don't lose a lot of quality, but of course there is no formal way to guarantee that there'll be no. Typically, it's empirical. It depends on the model itself, but in most cases, quantization is super efficient. But again, it's always a compromise for you if you want to improve latency and if you want to reduce cost. Quantization is something that I have no choice. Right. We take the same memory calculator that we've seen in the previous slide, and we see that if we change the precision, we see how the memory requirements changes. So we see basically if we change the precision, we reduce the memory required for inference and training. So, for example, if we are using int8, then it is actually possible to fit this large model into one GPU, especially if we're using A100 80 gigabytes. Same for training. This is a super powerful technique. Well, this is the slide, the updated slide for latency and cost. So we see if we apply this quantization technique, then we are able to serve Llama 270 billion parameters, not only one concurrent request, but actually 5 concurrent requests. We have smaller the worse latency because it's more concurrent. But as you see, we reduced almost 10 times, like basically eight times the cost for generating 1 million of tokens. Super powerful technique. Another technique which allows you to significantly reduce the costs and improve the overall efficiency of serving and training is called LoRa. LoRa stands for low rank adaptation. The main idea behind this is the following. Well, again, a large language model, the keyword here is large. It's any model is large, and it's very hard to fit it into their GPU memory. Because GPU memory is super expensive. So that we freeze the weights of the model, and instead of for example, training all of these weights and thus putting them into their memory, we only take a very small subset of all these weights, and we call it an adapter. So basically an adapter override only this adapter, which is a lot smaller than the original model. Then we train this adapter, and once we train this adapter, what we do, we merge this adapter with the original model. And then we get their fine-tuned version of their and just like with quantization, the point here is that we do it and we significantly reduce the memory requirements and time and cost and energy use without a significant drop in the quality. Again, it's only empirical data, and it depends greatly on the model at all. Proven is that this is a super powerful technique in a lot of cases, which doesn't make their model quality worse. Here is some more economical data. If we apply this technique, how the memory requirements changes. The largest open source model known by today called Falcon. And if we don't use any optimization techniques like LoRa or quantization, we see that in order to train this model, we would need 8 most expensive machines that AWS can offer, basically 5 terabytes of memory. And just by using LoRa, we reduce this more than 4 times. If we also apply quantization on top of LoRa, we see that, well, it's amazing, tremendous drop in the memory requirements, so making it possible to fine-tune this model even on a one. Right. There are, of course, more ways to do it, but we'll move on and talk a bit more about fine-tuning. So as you know, fine-tuning is a way to take a base model and continue the training using slightly different data set, aiming to improve the model behavior on a very specific any scale. They took, Llama, and they fine-tune it on 3 different data sets for different tasks. One is for functional representation, which is extracting structured data from unstructured data. Then code generation, generates some SQL files, and also solve. What they came to, like the conclusion they came to, is that for 2 first problems, they were able, by using LoRa, fine-tune the smallest model and reach the quality of GPT-4. So which is just another way to say that LoRa and fine-tuning of a small model in general is super efficient, and with specific tasks can not only match the quality of GPT-4, but actually exceed it. So for example, if your problem is structured data, like for example, you analyze scans of invoices and like to extract data, it is possible to fine-tune a small llama 7B, and this model will behave a lot better than GPT-4. There are several, there are many approaches to fine-tuning, and the most simple one is called supervised fine-tuning. Here you can see a very simple, a basic idea how it works. So the first one, here you see this, how when you take a lot of low quality data, and then train it for completion. And this is how you get a base model. And this is most expensive part of training an LLM. However, after and only completes low quality prompts, have low quality of completion. And in order to improve this quality, then you do supervised fine-tuning, which is just another way to say that you now start to feed high quality data, or also known as demonstration data, basically a bit more well curated data sets. Again, no human involvement is needed, rather than just preparing quality data, and then you get basically a model trained with supervised fine-tuning. And this is how Llama 2 base model was trained. Right, but then that's not all. Supervised fine-tuning can only tell your model what is good. Basically, you feel and say, okay, so this text is good, this text is good, this text is good. So your model learns which text is good, which texts are good, and it learns how to complete. So the text becomes good. However, in order to significantly improve the quality of the model and make this model and certain style and all, you, as study shows, you not only have to teach it what is good, but you also have to teach it what is wrong. And this is where the reinforcement learning from human feedback chimes in. Once you test a model, then you have to train it a bit different way, and this is called RLHF. You take another data set, but now you add labels to this text. Labels can be a score, text is, or just a classifier, like good or bad. And then you train a model which learns what is good, what is bad, and called reward model. This is an intermediate model, and only then you train the final model. There are two stages in this process, and it sounds as a bit complex. However, it's not that complex. In the end, you just need to add labels to your data. But it's quite expensive process, because you have to train an intermediate model. And this is exactly how Llama 2 was trained. Right. And recently, there is one more technique that gets quite popular, which you have to know about. It is called DPO, direct preference optimization, which is another way to where you don't train this intermediate reward model, but you directly train the final model using the same data, preference data. So you need the same data set, but you just train the final model without training an intermediate model. And there is a study by Hugging Face. So they took the Mistral and they fine-tune it using the DPO, direct preference optimization, to follow instructions. And what they got is that the final model bet llama, which was trained with RLHF. So basically, it's just another way to say that DPO is very powerful, and it can be easily compared to RLHF. Good. I guess that's most what I wanted to mention about open source. This is mostly beginner level, and this was the objective from my side to tell you, okay, so what are those basic things you have to know if you decide to leverage open source models for production, what you have to go and learn deeper. And this slide is exactly to give you direction for further learning. So if you start using open source LLMs for production, you'll be, of course, concerned about latency and about cost of fine-tuning. So there are three things that I would recommend you to read more about. First one is serving multiple LoRa's. This is an important approach. How you can significantly reduce the cost of serving models run through using LoRa's. When you load one original model, and then you can load many adapters, fine-tuned versions of that model, and this way you can use services to serve many fine-tuned versions. So super powerful technique. Then there is speculative decoding, which is an interesting read if you would like to learn how to increase the performance of your model, how to reduce the latency. Last one I'd like to mention here in this list is there are many ways you can leverage LLMs, not only open source but also proprietary LLMs, to improve data sets or to generate data sets or to label data. So basically, for example, to create labels or to create another data set. In this case, it's called synthetic data set, which means that LLMs can help you train other LLMs, which is quite powerful thing. Finally, concluding, I would just mention dstack, which the open source project I'm working with, and I would just say that in case you are interested in using open source LLMs and interested in using open source frameworks, consider using dstack. It's CLI and API that simplifies for you fine-tuning and deployment of open source LLMs. And the best part is that it's open source. It is compatible with any frameworks. Doesn't matter which frameworks you want to use. It's very easy to use any frameworks, and it works with any cloud of your choice, AWS or GCP, Azure, and it also supports many other providers, including those that offer GPU at significantly cheap prices. If that sounds interesting, check out the GitHub repo, and welcome to the Discord. I'll be happy to assist you. And having said that, Dmitry, I'm happy to see whether we have questions.
Yeah, thank you for this good overview and interesting overview of techniques for fine-tuning and improve the quality of LLMs. So we have the list of different questions. If you have still more questions, please ask them on Slander and we will answer for them. So let's start. What do you think about landscape of LLMs platform? What do you have any recommendation? And do you have any recommendation?
Right. Yeah. So I guess LLM ops is a relatively new term that we well got by replacing the ML in the ML, which is a funny thing. But the question is basically, okay, so what tools we can use to make the process of developing LLMs and the deployment easier, right? So I would say field is still being formed, and I would recommend personally not to try to learn how like other folks recommend, like what other folks recommend you in terms of the LLM ops platform, and learn how very specific tools work. What is their like path? What are their what are the frameworks that helps you reduce the latency and improve performance of your model? How to serve multiple LoRa's, and also instead of standardizing, I go and learn more about the fundamental questions, how these LLMs work, and not to lock yourself into one specific platform. And I would rather expect that this LLM ops space will evolve in the coming month. And it's probably a bit too early to use any specific stack. So I would just recommend you to go and learn very specific frameworks and tools that that allows you to do that, rather than being locked in a particular stack. Hope that helps. But happy to continue the conversation later.
Yeah, I can add it that, for example, I have some list of the tools which I use. So, for example, for labeling, I like use Label Studio. For tracking, very often I use MLflow. For training, automate the training and pipelines, I use or dstack or Ray. It's provides good opportunity and options to automatically scale cluster where the model will training, but you need to prepare all for this training. Also for serving, I like use Ray serve, and dstack also provide some options, and for some project I use dstack for store small model, but it's not for LLMs for now. Yeah, it's my list of tools which I like. Next question, how do you run open source LLMs? Do you use open source tool for that? Could you recommend some?
Totally. So first of all, I'd like to mention serving frameworks, and there are more than two open source frameworks. If you start with a few, text generation inference is one, which is cool, and it has a lot of optimization techniques. Then there is VLLM, another very cool project, also bringing a lot of optimizations. And then there are a number of tools that build on top that simplify deployment even more. Like, for example, Dmitry mentioned Rayserve and dstack as well. And there are a couple of helped with serving multiple LoRa's. But serving frameworks is the heart of it. So I would start with serving frameworks like text generation inference and VLLM.
Okay. So next question about limitation, open source and proprietary LLMs.
Right. Obviously, proprietary LLMs are they have very great quality for the general cases, and this is the level of quality which is really hard to beat. And if your use case is quite general, like for example close to ChatGPT, it certainly makes sense to use proprietary frameworks as long as you are not constrained by these concerns we talked about, like control, privacy, or costs. Those are several aspects where open source LLMs might, and I hope will, challenge to make it like short. I would say, if you are dealing with very specific domain specific problems, like for example classifying something, generating text with very specific tone of voice, and many more. It's really even hard to make a short list. If your problem is very domain specific, I would certainly encourage you to take a small model and do a number of experiments to you can have a great quality compared or even exceeding GPT-4. One downside with open source LLMs that you'll probably spend a bit more time with these experiments, and you'll have to tune their many NML challenges. So it's always a compromise for you. If you need something that works right now and you don't want to spend any time on this, so proprietary LLMs are great. But if you have time, you are free, you are open to experimenting, open source LLM thing to do.
Great, thank you. So next question, very interesting. And what are the potential legal issue with implementing deploying open LLMs commercially?
Right. It's one of those questions which are very hard to answer. As soon as you mention use the legal word there, then you typically would just say that any answer to this question when taking legal decisions, which is just another way to say that this question is just not possible to answer at all by design, unless you have a very good lawyer. But I would just say that open source LLMs, the more open source members of the community we have, the more companies use open source LLMs, the more safe it is to use open source LLMs. So basically, it greatly depends on the community and the quantity of users of these open source LLMs. So I would say that open source LLMs for safe use of these LLMs by business is huge. So I would encourage to use open source LLMs. But in the short term, of course, you have to be careful, and that's why, for example, it's always great to the data sets that you use for fine-tuning, or rely on data sets and or base models that come with some guarantees by some larger companies.
Yeah. So next one about RAG and PEFT. Can you describe these two techniques?
Yep. Right. Sure. So let me start with the last one. PEFT. PEFT is a library by Hugging Face for parameter efficient fine tuning. This library, the major thing there, I would say, is LoRa, most common way to do parameter efficient training. And this is a super easy and nice library. So I totally recommend you try this library. There are nice tutorials and all. Very easy to use. RAG is a broad topic, super broad topic. It stands for retrieval augmented generation. Is when you want to automate the use of LLMs by incorporating your data as context for text. Basically, LangChain and Llama Index are, to my knowledge, the most popular libraries there. They are quite powerful. They support many things. You can incorporate data from vector stores. You can from optimization techniques at all. I would just recommend you go and follow some basic quick start guides by Llama Index and LangChain, and you'll learn a lot just by doing this. But in the end, service is not that difficult. What is going to be difficult is to improve the quality of your RAG pipeline. As soon as you implement your RAG pipeline, you'll start wondering, okay, so is this pipe how costly is this pipeline? Does it use too much invocations of an LLM? How much do you spend per conversation, per request, and all? How efficient the retrieval and all? So there are many different questions. So doing it, and but how much difficult it is, you'll only learn when you start doing this for a real use case.
Yeah. So interesting question about. We know that there are way to train and fine tune LLMs. Why OpenAI doesn't use these methods?
Well, to be honest, I'm not someone who can comment on why OpenAI doesn't do something, or whether it's true that they don't do this. So I cannot really comment. Again, maybe if you could maybe make the question a bit more specific. What specific cheaper way of fine tuning you refer to, and then I'm happy to take this conversation also further. We can do that over Data Phoenix or dstack Discord if you join it. Happy to discuss this further.
Yeah, it will be, I think, good to have some discussion after this webinar on Slack, on our Slack, and on your dstack Discord as well.
Right.
Yeah. Next question about how to customize Llama 2.
Yeah, how to customize Llama 2. Yeah, let me also read the rest of the question. How to proctor and interact with students in lessons, guide them on how they got it wrong and how to do it right. So again, unless you specify, make the question more specific, I understand the question as, okay, so how do you leverage and customize Llama 2 for the education process? So how you can use Llama 2? Well, it's easy and difficult to say how you can leverage it for educational purposes. I'm pretty much confident that there are so many different ways you can benefit out of incorporating LLM into your educational process, and I would certainly encourage you to experiment doing for educational process, but even more, I would encourage you to try different things, even if you have a very rough idea, but you build some MVPs, you'll see, as long as you are open to experimenting. Secondly, Llama 2, yeah, it depends on greatly on very specific thing you try to do. RAG and fine tuning would be probably their most common techniques for customizing Llama 2.
Yeah. Interesting question about also, we not speak about multimodal models. So what you can recommend from the list of open source multimodal model? What is the best?
Mm-hmm. Well, again, yeah, this is another question which for me it's hard to answer because I'm not an expert. We're going to comment on that in the Slack channel. That's one thing. Secondly, I've seen some multimodal models, but what I personally feel, again, without being sure at all whether it's right or not, what I personally had a feeling for is that models you might combine normal models. Like, for example, you can combine a vision model with a text generation model with an audio generation model. So you don't need necessarily a multimodal model. Multimodal model, sorry. So I would encourage you to look for a way to combine different models of different modalities, not necessarily use multimodal approach.
Yeah. So more one question about inference. What are the techniques apart for speculative decoding for speeding up inference?
Yeah, except speculative decoding. So again, I'm not an expert here, and this is a super fast evolving field. And for example, VLLM and text generation inference, those two frameworks already, if you just read the documentation on them, they already list all the optimization techniques. They incorporate and point to see what things are supported, like batch processing, like different kind of attentions, paid attentions, flash attention, and many others. But I would also expect quantization is also is one more. So there are so many, and there are also this field evolves pretty quickly, which is cool thing.
Yeah, next question about use cases. Can Llama 2 be used for analyze fraud, or maybe some other interesting use cases for using Llama, not only for the chat?
Right, sure. Again, without doing this project myself, my course you can. Based on what I know, you certainly can. LLMs have proven that they are pretty efficient at many tasks that where classical machine learning was used before. And fine tuning is in this LLMs for very specific cases, like as an insurance, as classifier, and all. So totally, I would go for it. I would maybe recommend you to start with looking around whether this is something that the open source community done already. And then also, of course, something yourself, a couple of experiments, but be ready that you have to invest into making a data set.
Mm-hmm. Yeah. So next one about ChatGPT and about the report that it start to be less responsive.
Right.
Let
Yeah.
me, yeah.
Well, I mean, again, depends on whether you want to hear an honest opinion or a hyped one. A lot of hype about this, about ChatGPT in general, and there is a lot of shit talk as well about ChatGPT. I would not recommend to follow this hype and be more pragmatic. Whatever vendor you use, there is always a risk, and the service might go down. I don't think that long term there will be any availability issues with ChatGPT. In the end, it's in their best interest. Of course, if so many people use the service, they might see some availability problems, but that's not something that you can avoid at all. But what people started to recently talk about more after this thing is that it is great to have an open stack to switch between different providers. This is absolutely an important thing. And if you design a pipeline, I would certainly recommend and be ready to switch between providers if that's possible. And that probably might going to be a must-have for large companies. Yep.
Yeah, be ready to switching for now. I think it's a good point because every day we have new models, and some models can work for some tasks more better than other. So yeah, it will be good to have in architecture the options, quick switching between different models, different services.
Yeah.
Next question about other languages. So we know that English is one of core language for open source model, but with other language, it's not always work good.
Yeah. Well, it's a good point. However, two things to mention. There are open models for many languages already in the open source community, and we see even more models to pop up. So we can expect to have if not all, but most languages to be covered by base models. On the other hand, there might be some concerns over the fine-tuning, because fine-tuning can change the behavior of the model. So this is something to maybe dive deep, see how this language thing affects the efficiency of the fine-tuning. But again, I am not in a position to tell anything about it because I don't have this hands-on experience on this. But using open source LLMs is possible with other languages. It is certainly possible.
Next question about run LLM on customer grade hardware.
Consumer.
Consumer.
Yeah.
Sorry. Consumer grade hardware. If yes, which GPU would you recommend?
So
for training
yeah.
or for inference? It's good.
Yes. But even if I knew for inference or training, it would still be difficult for me. And I think there are other people that can answer this question a lot better. It is absolutely possible to use consumer grade hardware for running LLMs. It's always it is even possible to use LLMs without GPU. It's just a fact. So I would just recommend you to go and like LAMP CPP and which is the main one, and maybe a few others, and look at the architectures they support. So that's the very good starting point for that. But the answer is yes, it is possible, and there are many things, many options. Let's say, well, enough options.
Yeah, more question about speculative decoding. So, what other tools to accelerate open source inference you can recommend in front of speculative decoding?
Well, speculating decoding, I guess it's on a trial, and it's not that easy to use at all. It's not even incorporated into the most popular serving frameworks just yet, but expect it to be supported pretty soon. But many, I would just start with this most popular serving frameworks that already incorporated them. Unless you want to be on the very bleeding edge, but then you would probably have to learn about them yourself. So the question, but starting with serving frameworks and leveraging the techniques that already incorporated into these libraries is already a very good starting point. Like I said, this page attention, flash attention, like batch, different kind of caching at all. They all are incorporated.
Yeah, and last question about security, how to manage it, what is going on for now with security of open source LLMs?
Good question. I don't know. I can only imagine that it's an open question. There is none, I know. So if
yeah, I think it's more about how you build the inference of model, what standard you use for deploy them. Yeah, you deploy it in the cloud or in some private or local environment. Yeah, it's
so
depends of inference.
certainly, I mean, also the prompt injection is something that is most talked about. Then the data set, or governance is important. And of course, I guess what is critical is to have a process that addresses these security issues. In the end, it's never possible to remove all the security. We don't even know how many exist in the open source software we all use every day. But what is important is to have a process of having the security vulnerabilities reported and quickly addressed.
Yeah. Okay, it was our last question. I hope we will have more after when we will publish the video, and also all guys can come to our Slack channel or on Slack channel of Data Phoenix or dstack Discord channel. So we will be happy to continue discussion on these chats. So today, Andrey, thank you for your presentation. Thank you for your time and answer for all questions. thank you for all that you was with us and asked so many questions. It's, I hope, was useful for you. Yeah.
Thank you, Dmitry, and thanks everyone for your time. So excited to follow the questions over YouTube and Slack, and also welcome everyone to dstack Discord, where we can also talk about LLMs and also can help with the dstack itself if you decide to give it a try. Yeah, having said that, have a great rest of the day and take care.
Yeah. See you all on the next webinar next week. Bye.